A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, instructor for the NPTEL MOOC course, Pavement Construction and Technology, funded by Ministry of Education, Government of India. This lecture will be a part of Module 5. It will discuss the equipments and the construction process of subgrade as well as embankment in the construction of road pavements. So, at the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. When it comes to both embankment and soil, these are the layers which are usually constructed using the in situ soil or soil from a nearby borrow area, and if in certain cases if the soil is quite unsuitable, some stabilization may be required for making use it's in subgrade and embankment construction. Certain industrial waste also, for example fly ash, are also used specifically for the construction of embankment. Now, what it says about embankment? Embankment is a raised structure of earth as per IRC 75, which is there for the embankments having heights more than 6 meters. So, an embankment is a raised structure made up of earth or lightweight materials built above the natural ground to prevent water overflow and support a roadway, because we always want our road structure, the pavement crust to be sufficiently high above the high water level or the natural ground level. It is formed by using selected materials which can be obtained from cuts, borrow pits or by a combination of these materials. Then what it comes to subgrade, it is the top 500 mm of the foundation directly beneath the pavement crust. So, it is the under your normally sub base courses, what comes is your subgrade, and the top 500 portion of that particular one under that the pavement crust is known as your subgrade. It consists of in situ soil or a select soil from a borrow area or an stabilized soil and serves as the pavement's foundation. It plays a very important role because you construct your pavement over the subgrade. So, it is the foundation of your road structure. Well compacted subgrades provides high strength and deformation resistance. We have discussed earlier also, they play a significant role, and their strength is having a vital impact or a very important impact, especially on the performance of the pavement structure. And if you have a good subgrade or you have a subgrade with a good strength, it helps you to potentially reduce your pavement crust thickness. With a higher CBR value of soil, you can expect to have a lower pavement crust thickness. The embankment, now when we construct this particular one, as I mentioned, we want to keep the subgrade well above the water table or the high flood level. So, one statement is there, the embankment is constructed so that the bottom of the subgrade is typically 0.6 to 1 meter above the highest flood level or the natural ground level, whichever is higher. So, you will prefer to keep your subgrade well above the natural ground level or the high flood level in that case. And the various codes which are referred for the construction of subgrade and embankment are, you have this specifically manual on construction equipments for rural roads. We have guidelines for the design of high embankments, IRC 75. We have recommended practice for construction of earth embankment and subgrade for road works, specifically for subgrade and embankment construction. MORTH specifications for road and bridge works is there, and then we have the pocket book for road construction equipment, very useful to deal with the different kind of construction equipments. Now, let us see what are the steps which are involved when this construction of embankment or the subgrade is taken place in the actual field. So, this can be the main steps which can be outlined under this particular process is, first is cleaning and grubbing. So, we clean the ground over which the road crust have to be come up or the road is to be constructed. Setting out, we will discuss each of them in upcoming slides, is to come up with the fixing of your center line and the cross sections. Dewatering, if some water is present in that particular area, it needs to be removed. Stripping, whatever existing soil is there, we preferably try to remove a certain depth of it, and if it is good enough, we will keep it stored for later on to cover our side slopes, because it may be good for growth of vegetation. Then comes compacting, ground supporting, that once before we start putting up the layers of embankment or subgrade, the existing ground also needs to be compacted, made ready to take the layers of embankment or subgrade. Under that particular construction of embankment, it will involve spreading materials in layers and bringing to appropriate moisture content. We discussed about the determination of the moisture content, where the relationship between the moisture content and density to work out at what water content you can achieve for a given compactive effort a highest density, that is maximum dry density, and corresponding it to the moisture content was taken as optimum moisture content. Then once it has been brought, the material which is spread in one layer, when it is brought to the required moisture content, then it needs to be compacted. The layer after compaction should ensure that there should be no ponding of water, because there may be a rainfall event in due course of time. And finally, some finishing activities have to be carried out, side slopes have to be covered up. So these are some of the main steps which are involved in the construction of your subgrade or embankment. Now we will go to these steps one by one. Before cleaning and grubbing is there may be, because once you have acquired the land, in that case there may be a requirement of some preliminary operations. What that includes is, prior to the commencement of earthwork, the site shall be cleared for any obstructions, and whatever right of way is available with us, it should be made available for the construction activities, including buildings. So we may have to clear the existing obstructions which may be there in terms of some buildings may be there. So land acquisition is there, fences have to be removed, utility lines, there may be some electric poles in the vicinity that needs to be removed, abandoned drainage structures, old drainage structures may be there, and vegetations, trees, roots, undergrowth, grass, rubbish, etc. Other materials are to be there, which are to be removed within limits as per the requirement of the project. So as per your design requirement or the designs which are given for that particular project, you have to acquire the land, make it clear with all kind of obstructions. When we are removing, specifically when we are removing the removal of trees and undergrowth adjacent to the earthwork, which highly raises a concerns in different manners. One is, there is many a times it becomes quite important to remove these particular establishments, or to remove the trees which are near to your construction site within the construction area, because of some of the following reasons. We need to have an adequate site distance. If one is traveling, you can see, if one is traveling on this particular road, if there is some obstruction, trees is there, you will not be able to see the person coming from the other direction. So we need to make the line of sight clear, and it should be an adequate line of sight should be made available. Even this, so specifically at intersections also, similarly if I place some obstacles here, so one coming from this particular side may not be able to see what is there on this particular coming from this side. So you need to make the line of sight clear, and for this particular one you may have to remove some of the adjacent structures, or you may have to remove some trees or other obstacles, posts which are present there. First is to provide adequate site distance. Second is, because the landscape have to be improved. Once a new alignment is there, the landscape has to be improved, so that the nearby vicinity you are able to see what the existing features are there. So for improvement of landscape and offer views of nearby scenic attractions, it may be required to remove dead or decaying trees, because if there are old trees which are dead trees, there are chances they may fall over the road surface at later stage. And any obstruction which is present which hampers the drainage of the road surface, that needs to be removed. And other part is to permit access, because during construction there will be a lot of movement of construction vehicles, and you have to collect the materials. It may be the soil from nearby borrow pits. Then also you may have to remove some of the existing trees or some of the permanent obstacles there. So these are some preliminary requirements which are there. Now once the site is made clear, then the cleaning and grubbing needs to start, and where what is there, it involves removal and disposal of unsuitable materials, specifically exactly on the where you are going to have your formation width, or where exactly the pavement crust is to be constructed. So unsuitable materials may be in form of trees, bushes, stumps, roots, grass, weeds and organic topsoils. And specifically this organic topsoil is removed typically for a depth of around 15 centimeter. And if it is found good enough, we'll store it. We'll keep it nearby and can use it later stages, specifically for covering the side slopes, because the growth of vegetation over the side slopes to make them more stable will be good enough. So that's why if the topsoil is good, we'll store it for later use to protect our slopes. So we'll remove this particular one, and from the areas designated from embankments, drains, because we will have side drains. So specifically up to where your edges of your embankments will come up, till that point we'll go for this particular cleaning and grubbing actions. So it involves excavation and backfilling of pits with proper compaction. Now this is again important. When these trees are uprooted, there will be pits which will be formed, and they need to be filled back and compacted. So proper measures have to be there, because there may be big chunks of trees, maybe they are having a dia of even 2-3 meters, maybe more than that, and if they are removed, those pits are formed. They need to be properly filled and compacted. They should not be loose. That particular portion should not be filled by a loose soil and should not remain uncompacted. Cleaning and grubbing have to be performed in advance of your earthwork commencement, because you need to make your site ready for the placement of your embankment or subgrade layers. Now it says if the site has thick vegetation, roots, we have a crawler or a pneumatic tire dozer. This is an example. This is how it is getting cleared. So we can use. We'll discuss in the next part of this particular talk, where we'll discuss about the construction equipment. This is a dozer. It can be a crawler type or a pneumatic type, depending upon the site condition, the soil conditions. Of an adequate capacity can be used for clearing purposes. See, this crawler is clearing the existing site. It is doing the cleaning and grubbing exercise. So, and the dozer shall have ripper attachments for the removal of tree stumps. You can see this is the ripper attachment which can be there, and which help us to remove any amount of any tree stumps or any organic matter which is present. All tree stumps etc. falling within the excavation and fill lines shall be cut to such a depth below ground level that in no case these fall within 50 centimeter of the bottom of your subgrade. So this needs to be ensured, at least to the next 50 centimeter of the bottom of your subgrade should be made clear from all these kinds of trees, stumps etc. Now sufficient removal should be made to provide proper grades and connections with the new work. And many a times when we go with the widening parts, we go for widening parts. So there again, because the construction work has to be taken up, so we will do this particular exercise for a sufficient width to take up those works. The equipment used during clearing and grubbing operations includes a dozer, motor grader, hydraulic excavator, backhoe loader, ripper and tipper truck. We will discuss this particular one as mentioned in the second part of this particular talk. A good detail of regarding these construction equipments is available in IRC pocket book for road construction. Now once cleaning and grubbing is there, the important aspect comes up is the fixing of lines and levels of the roads. So this is important. After the site has been cleared, the lines and levels of the road, side slopes, drains, carriageway, shoulders should be carefully marked and checked. So this now comes the exercise of the surveyor team. They are going to put up these lines and levels through the help of the different kind of pegs which we are going to place here in this particular one. So, and we need to ensure that the correct slopes and cross sections are obtained everywhere. So because there may be horizontal curves also, vertical curves also. So we need to ensure that the correct slope and the cross sections are placed along the alignment of your road section. To facilitate the setting out of works, the center line of the carriageway or highway must be accurately marked. This is important part, that this is the center line of the road, this is the center line of the road. So we need to exactly mark the center line, and this can be done with the help of these better pegs which are there. So we can place those pegs. Here also it is shown that with respect to the center line of it, we are at 20 to 25 meter. We can place reference pegs, angle iron in concrete. So these better pegs can be placed. And at what distances, see, if we are going for an embankment construction, this is the height which is there to be attained. Now with respect to this is the slope which is to be maintained, and then keeping a margin, we will place some better pegs here. So these better pegs will help us to ensure the land in which the construction is to be taken up, and the alignment has to be properly maintained throughout the phase of the construction. The limits of the embankment subgrade shall be marked by placing better pegs on both sides at regular intervals. The embankment subgrade shall be constructed wider than the design dimensions to allow, and this is always good enough, because on edges it is difficult to compact, and then the natural slopes which are formed may not be good enough, may not be having a good density. So if I need to do this particular one, what I can do, I can construct them to a wider one, and then this I can remove this particular one. So I will have this one, I will have these slopes properly compacted. So this is much advisable. So it is said that they shall be constructed wider than the design dimensions to allow trimming of excess material, which can be done at a later stage, ensuring the finished section achieves the required density. You should have required density, especially densities at the edges are challenging part, and they should not be less than compared to what we have in the middle sections. To achieve the required density, alignment and the specified side slopes. So this is an important exercise, setting out your center line and the margins for your construction activities. So this comes the activity of the surveyor team at the construction project. Now thereafter comes the dewatering exercise. If there may be some existing water may be there, or water logging may be there, standing water may be there. So if the foundation of the embankment is an area with stagnant water, the same shall be preferably removed. Specifically, we can pump out the water so as to make that particular embankment foundation to be dry enough. Now during this particular one, we should take care that the pumping out of water should not damage whatever the nearby crops which are there, or the nearby some works or the property which is there nearby to your construction activity. And for waterlogged areas, some measures are prominently suggested, specifically by IRC 34/2011. It says, one, we can, especially in case of waterlogged areas, we can depress the level of subsoil water by some drainage measures. Some deep drains can be provided. Second is by raising of the embankment, and third is by capillary cutoff. These are given by IRC 34/2011. I will discuss some of them here. So one is, if you want to reduce the subsoil water level, one way of doing it is depressing the level of subsoil water by drainage measures. Here you can see this by providing drainage channels. We have provided the drainage channels at the end which are deep enough, specifically of a depth of 1.5 to 1.8 meters. So these are highly deep drainage channels which have been provided on both the sides below the ground level near the road embankment. Now this will help to lower the water table and keep subgrade above the capillary fringe. So this is one way we have. In this particular one, in these deep drains, we have weep holes. It are to be kept at a distance of around 0.75 meter of the depth of these drainage channels. Here you can see the slope is 1 vertical to 2 horizontal, which is mentioned here. So this is one way in which we can lower down, because the water will enter here and will move out. So, we are trying to lower down the water which is present in the subsoil. Second is, we can go for raising of an embankment. So, if this particular construction of these deep drains may be a quite expensive exercise. So, other way around may be that we can raise the embankment height, and will raise the embankment height in such a manner that the bottom of the subgrade remains at least 1.5 meter above the highest water table or high flood water level. So, this is again, if this is the high flood level, we will preferably try to raise the embankment in such a manner that your bottom of your subgrade is at least 1.5 meter above below the subgrade bottom. So, this is another exercise in which we can do we can protect our embankment or specifically the subgrade from the high flood level, because we know if the subgrade becomes indented or submerged, then there will be a loss of strength, and this will lead to some failures in your pavement structure. Now, the other measure which is normally taken in certain circumstances is the capillary cutoff, because whenever there is a high flood level, some water rises through with the capillary fringes there, with the capillary action it rises to a certain levels, and this rise will be more especially in case of fine grained soils. So, we can give a capillary cutoff. This is an example. So, it says where the water table is high and the soil permits rapid moisture migration by capillarity, a granular layer or a geocomposite. Now, here a capillary cutoff can be in the form of your granular layer. A granular layer is provided here. You can see this granular layer is provided here. So, you have this high water flood level which is there, at least to a height above around 15 centimeter of it. We are going to provide this capillary cutoff, which is a granular layer, and this is your capillary cutoff. And over now, what we are doing with this with respect of it, that whatever the water which are going to have from capillary rise from this high flood level will get captured through this particular one and will be taken out. So, will not allow it to reach to your subgrade level. So, it is mentioned that it should not be less than to height this particular one between your bottom of subgrade and the capillary cutoff, at least a distance of 0.6 meter should be there. So, this or in addition to this granular layer, we can go for a geocomposite one. Geocomposite can be a geomembrane on the underside, because it allows to water, and a geotextile filter on the upper layer. So, it will act as a filter or as well as a separation layer. So, a geocomposite can also be done, but this one is preferably done when a new construction is there, because with laying a capillary cutoff is possible when you are doing for a new construction. The capillary cutoff shall extend across the full width of the embankment, and this is another important aspect. It should extend to the entire width, and it should have a proper slope also. So, during the construction of embankment also proper slope should be maintained, because when you are going to put up the capillary cutoff layer, it should, with the help of the slope only, the water will come out through this capillary cutoff layer. The surface on which capillary cutoff is provided shall be maintained with a minimum cross fall to ensure effective drainage. And what type of materials can be used and what thicknesses have been recommended, this is again given as per IRC 36/2010, which says if you are having a subgrade of 0.6 to 1 meter above the high flood level with a plasticity index of greater than 5, then if we are using a fine sand as a capillary cutoff, 425 microns to 2 mm, a thickness of 350 mm is required. Coarse sand 2 mm to 4.7, this thickness is required. And if we are having a subgrade 0.6 to 1 meter above high flood level with a plasticity index less than 5, specifically for sandy soils and sand content not less than 50%, this thickness will be there. Different thickness have been recommended as per IRC 36 for the capillary cutoff layers. Now, once the dewatering action has been done, and before you start with the construction, as mentioned, you will preferably store the topsoil from cutting areas and embankment foundations to be stripped to a specified depth, normally in the thickness of 15 centimeter, and stockpiled not to a height greater than 2 meter for later use, specifically if it is good enough for embankment slopes, cut slopes and other disturbed areas, because which prefer revegetations are required so as to make your slopes stable. Now, many a times you may have to select some materials from some borrow areas, because the existing soil may not be sufficient enough or may not be good enough to meet all your requirements in that case, because you may have to raise your level, and for raising that level the quantity required is more is good enough. So, then you have to you will try to select a borrow area nearby only, and while selecting this borrow area, certain precautions have to be taken up. So, borrow areas are when earth is borrowed from land near the embankment, the following principles are generally followed for the location, depth and drainage of borrow pits. The certain aspects need to be taken up. If a construction has to be taken up here and I need to select a borrow area here. So, you can see a borrow pit needs to be selected. What says? Use of earth mainly available from road cuttings and excavations is recommended. Whatever you are getting through the cuts in the cutting areas or through excavations, will first try to use that particular one. If that is not found suitable or is insufficient, then we will go for borrow pits, preferably rectangular in shape, with one side parallel to the center line. This is another one side of it. If this is our center line, this will be parallel to the center line. No borrow pit should be dug within 5 meter of the toe of the final section of the road pavement. This is another important aspect, that within the toe of this particular one, it should be at least 5 meter away from the toe of your embankment. It should not be very close to your embankment toe. The depth of the borrow pit should be so regulated that the borrow pits do not cut an imaginary line, and the other aspect is the slope. It should be, the edges should be in such a manner, if we draw an imaginary line with a slope of 1:4, then it should not cut the borrow area. So, this is an imaginary. If I am doing, for say, this is the widening part which is to be attempted, and this is the width up to which it is attempted, then an imaginary line is drawn here with a slope of 1:4, and this should not cut the borrow area. So, this is again to make your structure stable enough. So, it says the depth of borrow pit should be so regulated that borrow pits do not cut an imaginary line having slope of 1 vertical in 4 horizontal, protected from the edge of final selection of bank. So, this is to be finally selected for your this embankment bank which is getting created. Now, when we are going to place the layers, the existing land needs to be compacted. So, the first layer of, whether it is the first layer of embankment or the first layer of your subgrade, the foundation over which it has to come up also needs to be compacted. So, the compaction, and why compaction is important? Compaction forms a very important activity in any of the road construction activities, whether it is a construction of the embankment, subgrade, or construction of granular courses, construction of bituminous bound courses. Compaction plays a very important role, and the primary purpose of soil compaction is to enhance its engineering properties by increasing the density. When we do compaction, we increase the density, making it strong enough to resist deformation under applied roads. So, we are improving enhancing the density with the compaction which is given to the soil. Now, the principal properties affected by compaction as stipulated in IRC SP 97 2013 guideline on compaction equipment for road works are mentioned here. What we get out of the compaction or the enhancement which are expected out of the compaction is enhancement in the structure strength, enhancement in the load bearing capacity, stability of the fills. When a lot of filling has to be done, the stability of the fills is there. It makes impermeable so that the water does not enter into your pavement structure easily. So, when you increase the density, the impermeability increases. It allows it does not allow water to easily enter into your pavement structure, and the shear strength of the soil increases. So, we have poor compaction will have more deformation under the wheel loads, good compaction will have less deformation. Poor compaction will make your soil more susceptible to freezing actions, freeze and thaw actions compared to a good compacted soil. Even poor compaction soils will increase the permeability, will make your surface more permeable to water compared to a good compacted soil layer. So, we will first prepare the foundation over which our embankment or subgrade layers have to come up. So, the original ground shall be first leveled to facilitate the placement of the first layer of the embankment. So, we can scarify it. So, we can initially the top layer can be scarified, mixed with water and then compacted by rolling so as to achieve the required density. If it is already an existing embankment, it needs to be recompacted because that compaction might have done a few days before. So, you may have to recompact that particular one, and when we recompact it, we actually try to get certain targeted densities. It says that when embankments are to be constructed, embankments up to 3 meter height should not have a density of less than 1.52 gram per cc, or when embankments exceeding 3 meter height is there, the density, this is not typically for fly ash. For fly ash the requirements are different. This is for typically when the embankments are constructed using the soils. So, here when the height of embankment is more than 3 meter, the density should be greater than 16 kilonewton per cubic meter, and when it is to be used in subgrade, it has to have a density more than 17.5 kilonewton per cubic meter. Now, this is the laboratory determined density at a given optimum moisture content. Now, the density which is to be achieved will be a percentage of the density, the maximum density which we get in the laboratory. So, if the difference between the subgrade level, and there may be another important aspects, if there is a natural ground level which is there and the subgrade which you have, the top of the subgrade, if this particular difference is less than 0.5 meter, if this difference is less than 0.5 meter, you need to cut it down. This is your top level and the existing ground level. So, here in this particular case, what will happen? I will show you. If this is my existing ground level, and after compaction the subgrade top should be here. So, existing ground level, then the difference between this particular one, if it is less than 0.5 meter, then I have to cut it down. For this particular subgrade, I have to cut it down. The entire natural soil has to cut it down. It has to broad. So that, and then I will do the recompaction of this entire 0.5 meter. I will not leave this layer which is within this 0.5 meter thickness recompacted, because I need to ensure the density of this particular, the density and composition of this particular material in this 0.5 meter of thickness. So, it says if the difference between the subgrade level, top of the subgrade and ground level is less than 0.5 meter, the ground does not achieve a 95% of its relative, because as I mentioned, in field you have to achieve a percentage of your laboratory compacted density. So, for subgrades it says it should not be less than 97%, for embankments it says it should not be less than 95%. And then there is a expensive clays are there, subgrade and 500 portion just below the subgrade, these are not allowed, but when remaining portion of embankment it can be 90 to 95%. So, anything just near under the subgrade will be your embankment, and that should not be having a density less than 95% of its maximum dry density. So, we need to ensure that it is not compacted. If it is subgrade and the natural ground level and the subgrade top, this difference is not there, then I need to ensure that this entire is to be at a 97% of the laboratory maximum dry density. So, with respect, so it shall be loosened up to 0.5 meter below the subgrade level and then watered. And for recompacting it, I need to water it. The required amount of moisture is to be added to achieve the optimum moisture content, and then compacted in layers. So, there may be a case that your subgrade top may be very close to the existing ground level. So, in that case you have to cut it down, bring it down to the depth of 0.5 meter, entire the soil has to cut down, and then the construction has to be brought up from this particular thickness to the your subgrade top. Here, when you are spreading the material, one important aspect is how do you spread it and how do you reach your optimum moisture content. So, embankment and subgrade material should be spread uniformly in layers, and a particular layer thickness should be followed depending upon your compaction equipments, how much they can compact in one go. So, uniformly spread in layers across the full width, preferably using a motor grader. This is again when we will discuss construction equipments, we will discuss this in detail. This is a motor grader which have a blade, which have a movable blade. So, it can spread the soils, it can help you to maintain the grade as well as the cross slope. So, this helps us to uniformly spread your soil to the entire thickness, entire width, and help you to maintain the grade also. The graded blade must have hydraulic controls because it can adjust the angle and initiate to maintain the specified slope and grade, because we will prefer to do it from the subgrade itself, because otherwise if some rainfall event is there, water logging will happen. So, we will try to maintain our grades and cross slopes from the construction of the subgrade itself. Each compacted layer shall be finished parallel to the embankment's final cross section. So, when it is an embankment is there, we will do this final foundation construction at the required cross slopes. When using a vibratory roller, now while how much layer thickness you can put up in one go, because it depends upon the compaction equipments which are available. If we are using a vibratory soil compactor, then we can go for a compaction of a thickness of around 250 mm. This is the compacted layer thickness. The loose layer thickness will be a bit more than this, and this how much will be the loose layer thickness to achieve the compacted thickness of 250 mm. We will go for trial stretches. So, trial stretches, a particular length can be laid there in the field, watered, and then we will look how much amount of compactive effort of different passes are required to reach to this laying of the decision on the compaction. It is very important if it is done, or very useful if it is done with the help of the trial stretches. So, for different types of soils, we will go for trial stretches, we will put those soil, we will decide how much compactive effort, how many passes of a particular type of roller is to be applied over the soil layer to achieve the desired compacted thickness. So, you will put the loose layer, and it says that if you are using a vibratory soil compactor, it can particularly be good enough to compact, to have a compacted 250 mm thickness. If there is an static 80 to 100 kilonewton roller which is there, then you should preferably go for a compacted thickness of 20 centimeter 200 mm. Now, so for this particular one, once the loose soil is spread over the foundation or the bed which has been prepared for it, so it is an embankment layer or it is a subgrade level. If once the foundation is prepared, the loose soil is put over it, it is spreaded with the help of a grader or dozer, and then now the requirement comes to see what is the current moisture content in their particular soil. So, moisture content of each layer has to be checked in accordance with IS 2720 part 2 and shall be adjusted. Now, it needs to be adjusted so that to achieve a range which is in the range of 1% above and 2% below the optimum moisture content, because there will be some loss of moisture may be there due to evaporation. So, we will try to keep this particular one which is at least plus 1% to minus 2% of your optimum moisture content, which was derived through IS 2720 part A, which is for heavy compaction through a Proctor test. So, there what moisture content, if that moisture content derived optimum moisture content was derived as 10%, we will try to go from 9 to say 12% in that case. We will ensure that if it is not there, if we find that the water content is less, then we will need to sprinkle the water over it, which is done through water tanker fitted with sprinkles. So, they have to have a uniform distribution of this particular one. Now, to the entire width, and then we can do some again remixing of this water if required with this particular water and the soil. and thereafter, so once this particular one is done, and there may be certain cases where the soil may be at higher moisture content, much higher moisture content than what is its optimum moisture content. So, we have to leave it uncompacted, we have to aerate it for a given period of time, so that the excess moisture content is lost through evaporation, and then the compaction process has to start. And we need to ensure that during this is a uniform sprinkling of water is happening. There should be no flooding, because if flooding will happen, then again, and flooding may happen if the proper camber is not there, and in that particular case we need to also ensure that if at certain locations some excess water has been applied, then that particular section or a part of that particular stretch needs to be aerated to bring down the moisture content to the required moisture content for your compaction. And as I mentioned, once this particular water has been added, we can mix it with the help of the graded blades, or it can be mixed with the help of using disc harrows, which are quite often used specifically when you are mixing soil. So, this can be used if once you have spread that particular water, disc harrows can be used. That gives a uniform mixing of it, and then you go with with the help of the graders, again putting up the soil to the required cross slopes. So, you can see these disc harrows are mixing the water with the soil, and then you can have these graders which can bring this soil having the required moisture content to the required grades at that particular level. So, after watering, the soil has to be processed using graders, harrows, rotary mixers or other approved methods to ensure uniform wetting. Now, this exercise is completed, then comes the compaction. So, this compaction can be done, as I said, with the vibratory rollers also, with the static rollers also, depending upon the compacted thickness. Vibratory rollers can give you a compacted thickness of 25 centimeter, and static rollers will give you a compacted thickness, are good enough for a compacted thickness of 20 centimeter. So, the compaction is preferably done with the help of a self-propelled single drum. This is a vibratory roller, or a pad foot vibratory roller having 80 to 100 kN static weight. We will discuss about these different type of construction equipments, rollers, dozers, the harrows in the later part of this particular talk. So, here just to give an example. So, now once the soil has been brought to the cross slope with the required amount of water, the compaction needs to be started. Each layer has to be thoroughly compacted. So, this is the important. If I need to construct a subgrade which may of a thickness of 50. So, this is if I need to compact it for a thickness of say 0.5 meter, that is your 50 centimeter. Now, if I am having vibratory rollers with them, I can do this particular one in 2 layers. So, one may be 25 centimeter, other may be 25 centimeter. So, for subgrade construction, if I doesn't have these vibratory rollers and I am going with the static rollers, then I may have to compact the layer thicknesses of 20 centimeter, compacted 20 centimeter, and the top one will be your 10 centimeter. So, instead of doing in this particular manner, the other way around I can do it. I'll go for the bottom one of 20 and followed by the top 30. If I am going with the static rollers, I will prefer to have it 15 centimeter and 15 centimeter. So, the remaining. So, this needs to be ensured, and each layer thickness needs to be ensured. If density measure indicates, and while compaction you can see certain loose spots are there. So, the loose spots may be there, that while compaction either the moisture content was quite high, or at certain locations the compaction specifically was not done properly. So, you may have to again add some water and do some recompaction. So, at many a times if you move over the layer of the soil, you can from your visual examination you can come to know that this particular portion is compacted well or not. And then definitely we need to do the laboratory measurements to ensure that the density is achieved or not. But yes, during the compaction process itself, through your experience you can get an idea whether this particular part requires more compaction or not. Once compaction part is also complete for one particular layer, then it says that the drainage and finishing operations has to come up. So, the surface of the embankment or subgrade at all times during shall be maintained at such a cross slope not flatter than required for effective drainage. As we have mentioned, if we are using even the capillary cutoff layers also in new construction, we have to maintain them at such a cross slope not flatter than the required effective drainage of earthen surface, because otherwise if it does not have a cross slope, if a rainfall event happens, then the entire layer will get saturated and it will take many days to aerate it and bring it make it ready for the next layer. So, it is always required that you construct your subgrade layers and the embankments with the required cross falls. Finishing operations, now once we have done this particular one, the slopes of the subgrade and embankment have to be done. So, the finishing operations typically involve shaping and dressing of the shoulders, earthen shoulders are there, verge, road bed and the side slopes to conform to the alignments. As we have mentioned, we need to ensure the side slopes are to the required levels and are as per the cross sections, so which are shown on the drawings. Both the upper and lower ends of the side slopes, the upper end and the lower ends are to be rounded off. This is again important, they should not be sharp ends which are there at the top as well as at the bottom, to improve appearance and to merge with the embankment and the adjacent terrain. So, this is important, this is good for stability also. And as we mentioned, during cleaning and grubbing, the topsoil which we have removed, if it is good for vegetation growth, will put that topsoil over these side slopes, and this will help us to facilitate the growth of the vegetation, and typically it is laid in a thickness of around say 75 to 150 mm. So, this is how the operations which are involved in the construction of a subgrade, where we begin from the clearing of the site, we do the cleaning, grubbing, we do the setting of the center line, then we are going to ensure the making of the foundation for putting up the layers of embankment subgrade, where individual layers the soil is to be laid, then the soil has to be ensured for the required moisture content, thereafter the compaction has to be done over it. So, these are some of the salient points which are involved in the construction of subgrade. Thank you.